This one's really good fun. The Death
Yeah.
Star, Terry.
Yeah. Anybody who's interested in astronomy probably knows something about a supernova. And if you know anything about the night sky, you probably know about the star Betelgeuse in Orion. And in fact, within the last year, we were talking quite a bit about the possibility that Betelgeuse was going to become a supernova. Now, I'm not going to go into the details of the astrophysics too much, but basically, if you get a very large star towards the end of its life, which is relatively short in comparison with the sun because it goes through its nuclear fuel much more quickly. Basically, it will start to expand and burn as it burns up all its nuclear fuel. That means that the radiation pressure, which is keeping the star as distended and bloated as it is. And Betelgeuse, for example, is about the size of between the Earth's orbit and the orbit of Mars in size, huge. Some of them are much bigger than that. And that is kept at that size by the pressure of the radiation coming from the nuclear reactions in the center of the star. Gravity, of course, is trying to collapse the star. The radiation pressure keeps it the size that it is. When it runs out of nuclear fuel, that radiation pressure stops and the star starts to collapse under gravity. And one of the most frequent questions that any astronomer ever gets asked is, when is Betelgeuse going to explode as a supernova? And if a supernova goes off near the Earth, what's the consequences going to be? So it's a really fascinating topic. And for the first time ever, astronomers have now actually witnessed the full progress and stages of this type of supernova explosion. There are two main types and another smaller subset, and they're divided into further subsets. But basically, this is called a type 2 supernova, and it's the way all really large stars, bigger than about 1.5 times the mass of the sun, are going to end their lives. We'll go on to sort of the other side of that coin later on, a separate topic. So Betelgeuse is the brightest and nearest of the really big red supergiant stars. And just about a year ago, it started behaving a bit oddly, and we talked quite a bit about whether that was going to be a precursor to it going supernova. But what has happened so far is that we have seen many hundreds of these supernovae going off, mainly in other galaxies, because there hasn't been a good one in our own galaxy since, 1600 and something. What we see when we see a supernova in another galaxy is when the explosion has already happened and the star has increased in brightness by a factor of about 100,000. Sometimes we see them just before they reach their peak, but we never see them up to now until the explosion has actually occurred. So what happened is that there's a group of astronomers who have been studying potential supernovae candidates using mainly Pan-STARRS, which is a wide field survey telescope. And they were monitoring this star, which is, I've forgotten, it's a galaxy about 120 million light years away in the galaxy NGC 5791. Not something I knew off the top of my head. But they monitored it and they started seeing it behaving rather oddly. It increased in brightness. The spectrum changed to show that it was throwing out quite a bit of material from the surface. There are other changes which I didn't go into. That happened in the summer 2 years ago. And what they discovered then was in the autumn of that year, it did finally go supernova. It finally exploded. But they had been able to monitor it for the 120 or so days, or 130 days, I forget exactly what, during the phase when it first started to become unstable and then actually exploded. And that's the first time that we have ever witnessed the actual supernova explosion of a type 2 supernova from start to finish. They increase by a factor of 100,000 or so or more in brightness. They're already very bright stars to start with. Sometimes a supernova can be as bright as the whole galaxy that it appears in. And then over a period of months or so, the brightness fades away as the expanding shell expands and cools down, and the various radioactive elements become less radioactive and so on. So this is really fascinating. There are quite a few surprises. They were quite surprised to see some of the events that happened in the build-up to the actual explosion. But they now know that not all of these supernovae explosions are the same. They're monitoring over 100 of these stars, and it's quite likely that within the next few decades or so, we'll see another one go supernova. Whether that will apply to Betelgeuse or not, we don't know. The usual answer when somebody asks you, when is Betelgeuse going to go supernova, is it could be tomorrow or it could be a million years from now. It is going to happen, but we just don't understand all the processes well enough to be sure. But what we now know is that in this particular case, the star did brighten and become rather unstable before it actually exploded. So last time we were observing the odd behavior of Betelgeuse, it actually faded because it threw off some dusty material which blocked some of the light. If you see Betelgeuse start to brighten considerably above its average magnitude, then it's really going to be worth keeping an eye on. Over to you, Nick.
Yeah, it's really interesting, having observed and imaged many supernovas over the years. They are fascinating to watch, and there's some great examples of ones that get missed. The amateur astronomers pick these up all the time, because the professional sky surveys, obviously, typically what you'll get first with a supernova explosion is a detection of neutrinos. So there's large kind of neutrino tanks basically in mine shafts and buried deep underground all over the world, and now they've got quite interesting capabilities in terms of being able to almost triangulate where the neutrinos have originated from in the sky. So you get a neutrino burst typically before you'll see the supernova kick off, and this is quite common now, but still amateurs are picking these up. So if you've got an interest in stars, star birth, etc., and you're interested in particularly in spectroscopy, which is when you get a kind of slit and a specialized filter that allows you to split the light into all of its components, and then you can see these dark lines and bright regions within the spectra that show you the chemical composition of a star. This is a really interesting part of even amateur astronomy, especially if you're tracking things like supernovas and watching how they evolve, because they have very definitive spectral lines. So it's a great story, and I love this, and the fact that it's the first time that it's really been seen throughout its full evolution. And you said, we haven't really had a good one in our galaxy. We had SN 1987A, obviously in the southern hemisphere, back in 1987.
That was a satellite galaxy.
Absolutely, not even our own galaxy. So we are long overdue a big one in our own galaxy. And given that there's 450 billion stars, or anywhere between 250 billion and 450 billion stars estimated in our galaxy, we are long overdue. I mean, we've got nearby galaxies like Messier 31, M81, M82, etc. There's a really good supernova out there, not so long back, that was picked up, I believe, by some students at one of the London universities first. Because again, lots of people, when they're imaging it, imaging these galaxies, they tend to kind of image based around creating really pretty pictures, and they tend to kind of overblow some of the regions where you may get supernovas kicking off. So it was an interesting find. I remember that a few years ago, but I love this. It's a really, really good story. And if you are interested in stars, just have a look at some of the stellar comparisons, some of the size comparisons between our sun, as Terry was saying, only needs to go about 1.5 times the size of our sun, and then you're going into supernova territory. But some of the stars literally would fill our entire solar system that are out there. So it's well worth kind of doing a bit of background research if you're interested in this. Great topic.